All right, so today we're looking at soil. We're looking at soil. Okay, so what is soil? All right, when you walk outside and you pick up some dirt, you gotta think about what's in that dirt, all right? Because you probably walk out it all the time and you probably never really think about what's in there. Well, what dirt mostly is one, little broken up rock particles like sand or little pebbles or things like that, which are all just, again, broken up rock particles. Something else that's in dirt or soil is organic matter. And what organic matter could be a variety of things. It could be like dead leaves or dead animals, or it could be like the roots of plants. It could be feces from animals. So something that's coming from a living thing. And the rest of what soil is, assuming it's dry soil, is air. A lot of soil, if I have a beaker full of soil, probably half that beaker is filled with air, or it has like 50% porosity to it. If the soil is wet, then it'll be filled in with water, but air or water, all right, assuming the soil hasn't been packed out. But anyways, so of the solid parts, it's mostly broken up rock material and organic matter. Now the percentages can vary quite a bit depending on where your soil is from, but that's what it mostly is, all right. So soil is the part of the ground that will support rooted plants, all right. So if a plant, if you could plant a seed in it and its roots will start growing and so forth, that's basically what soil is. And another term that's used for soil sometimes is regolith. So you might see the word regolith used sometimes. And since soil is mostly made out of little tiny broken up rock particles and organic matter, the two things that create soil are, it's a product of weathering. Because remember, weathering is a process where big rocks get broken down into small pieces. So since soil is basically made up mostly of little tiny broken up pieces of rock, it's the process of weathering that's responsible for that. So soil is the product of weathering and biological activity. So biological activity is pretty vague. It's just some activity from some sort of living thing. So again, it could be dead leaves, it could be roots from a plant, it could be dead animals, their bones, or it could be animal feces, just something like that, organic stuff. Right. Now, let's say I was gonna dig a hole in my backyard, all right? What I would probably notice if I was digging a hole, 8 feet down or something like that, is as I'm digging down, what I'd probably notice is that the soil is not the same the whole way down. All right, soil is not the same the whole way down. The soil near the surface is going to be different than the soil farther down. So what I might find is that I might have like one for like the first foot or so. I might have a black organic soil where it's mostly like dead plants and stuff like that. All right. Then beneath that, maybe I have 2 feet of soil that maybe is like tan, sandy soil. And maybe beneath that, I might have 2 feet of soil that's like a gray gray clay soil. And then down here, maybe I have 3 feet of very rocky soil. All right. So as I'm digging down, there's a good chance I'll notice the soil is different at various layers. All right. Now, each one of these layers of soil is what's referred to as a soil horizon. So a soil horizon is a layer of soil with certain characteristics. All right. So this is one soil horizon, another soil horizon, another soil horizon, and so forth. Each one of these would be a soil horizon. Now, if I take all these soil horizons and I put them together like this, this creates what's known as a soil profile. So a soil profile is kind of like a model that shows you what the soil's like in a certain area. All right, so if I had this here, it gives me a good idea what the soil's like. So it's not just one of the layers, it shows me what all the layers are like. And the reason why I might want to know this is, like, for example, if I'm putting in like a septic tank. For a septic tank, you need a ground that's going to let the water pass through it very easily. All right. Well, clay soil, clay is a really, really tiny particle size. Clay doesn't let water through it very easily. So you probably don't want to have things trying to drain into the clay soil because water's not going to soak into it very easily. So things like that is why you might want to know what the soil is like at certain depths. Or if you're a farmer, some crops may want a certain type of soil, so you might want to know what the soil underneath it is like. So one layer is the soil horizon. The layers combined make up a soil profile. It's basically a model of what the soil is like in an area. All right, now, how you get soil to form. All right. Well, there's basically two ways in which your soil forms. Residual soils and transported soils. Now, a residual soil is one that forms in place from the rocks beneath it. So let's say I started off with some solid rock. What's going to happen to that solid rock is, so like here's the surface right here. Right? Eventually that surface area is exposed to the elements, exposed to the sun, it's exposed to change temperatures, exposed to the water. And what will end up happening is eventually you start to get little cracks in there. Right? And once they start to get little cracks, that's going to let the air and the water get down even more. And as soon as it breaks up a little bit, what you might end up happening is you might have, some seeds from some plants might get down in that crack, and you may get a little bit of water, and you might get some plants that start to grow. All right. So you start off with solid rock. Now, because of weathering, the top here is starting to break up a bit. Now, as more time goes by, the water and stuff can penetrate further, and the air can get down further. You're going to get more weathering. The more it cracks up, the more weathering you're going to have. So as time goes by, maybe the cracks and stuff, the part that's broken up might be like this now. All right. So here, the solid rock was pretty much right up to the surface. So you only had to go like a short, there's just a little tiny broken up part at the top. And the solid rock's right near the surface. But as time goes by and this breaks up more and more and more, the water could penetrate farther down, the air could penetrate farther down. The plant's roots get in there. So I start to get root action starting to break the rocks apart. So now the part that can hold plants is more broken up, which allows even more plants to grow. So now this part here is all broken up, and the solid rock is down here. All right. So now the part of the solid rock is now farther down because the top of it keeps breaking apart because of weathering. All right. And the more it weathers, the more plants and stuff that'll grow, and that's going to produce even more weather. Now, as more time goes by, what I'm going to end up with now is the broken up rock part is like right there. Right there's the broken up rock part. But now at the top, what starts to happen is these plants start dying, and when the plants die, they become part of the soil. So I end up with this layer on top here, which is mostly, and again, the more it breaks up, the more plants can grow, which causes it to break apart even more. So I'm starting to get all sorts of plants growing. But this top layer here is made primarily out of these dead plants, all right? So this top layer here is not made out of broken up rock particles. It's mostly made out of dead plants. So this layer that's pretty much all organic matter we call humus, right? Not hummus, stuff you dip pita chips in. That's got 2 M's in it. This is humus, all right? So this is pretty much all organic matter. Down underneath it, you have broken up rocks. The layer is mostly like broken up rocks. Now the solid bedrock, the solid rock is way down here. So as time goes by, basically the broken up rocks and the humus are the soil. So what's happening as time goes by is the layer of soil is getting thicker and thicker and thicker, and the solid bedrock is getting farther and farther down because the top of it's getting broken up. Now the formation of soil is a pretty slow process. On average, it takes about 100 years to make 1 inch of soil. That's why it's so important to prevent erosion. Like for farmers and stuff like that, they want to slow down or prevent erosion because it doesn't take much for some of that soil to wash away. And again, it takes like 100 years to make about that much soil. So it's a pretty slow process. All right, so that's a residual soil. That's a soil that comes from the rocks beneath it. Now, chemically speaking, with a residual soil, since all this broken up rock material is just this rock at one time, just broken up, chemically speaking, with the residual soil, the soil is going to match the chemical characteristics of the rock beneath it. So if this bedrock right there was all limestone, then the soil right there is going to be primarily broken up pieces of limestone in it. Or if this was a broken up piece of sandstone, if this was sandstone, this would be broken up pieces of sandstone right there. So it'd have lots of silicates in it right there. All right. So with the residual soil, the soil chemically matches the characteristics of the bedrock underneath it. All right. Now, most soil is not residual soil though. Most soil is what we call transported soil. Transported soil is soil that moved from its place of origin by glaciers, rivers, winds, etc. So in New York State, most of the soil we have here is a transported soil. And the reason being is about 10,000 years ago, New York State was covered by glaciers. And what the glaciers did is on the way down, scooped up all sorts of junk from Canada. And as the glaciers moved south towards New York State, then as the glaciers start to melt back, it just dumped all that junk around here. So in New York State, a lot of the soil we have is just a lot of this mixture of junk that the glaciers left here. So that's why you can dig up and find rocks that like really don't belong here whatsoever because they didn't form here as the glaciers dumped them here. So the rocks don't match the surroundings. Right? So transported soils are moved from its place of origin by glaciers, rivers, winds, etc. Most soils, including those in New York, are transported. All right? So that's how you get soils. All right? And remember that soil is a product of weathering or erosion if it's transported. All right?